In this video I am going to show you how to control a 4-servo motor robot arm, like the MeArm or one of its clones, with an Arduino Uno style controller. Adding 4 potentiometers, we will be able to control each of the servo motors individually. We will cover how to set up your hardware and software so that you can control your robot arm easily. The example robot arm used in this video is a MeArm version 3.0. The MeArm was the first small desktop robot arm that was designed to introduce students into the concepts of industrial automation. It was launched in 2014, and has been copied millions of times since. Just about every robot arm kit for Arduino you can buy is based on this simple design by MeArm Robotics. Because of this, the instructions in this video will work with many similar looking robot arms, whether you've purchased them from MeArm Robotics, got them from Amazon or eBay, or made them yourselves from files found on the internet. So this is the right video for you if you want to control any 4-servo motor robot arm, using an Arduino. We'll cover the building of the robot arm in another video. Now let's move on to what we need to get started controlling our robot arm. For this we will need the following equipment: a MeArm kit, or similar robot like the EasyBot arm, an Arduino controller board. We'll be using an Arduino Uno R3, a computer, PC or Mac, a USB cable to connect the Arduino controller to your computer, a power supply that can give 6 volts for the servo motors, a solderless breadboard. These are so you can prototype and change your designs and wiring easily. 4 potentiometers. These allow us to give a varying signal to the Arduino controller. You can get all kinds of different potentiometers, but we'll use simple rotary ones. People sometimes call these pots for short. Jumper cables. These are to connect all our components together. Links for all of these are in the description below. We'll also need some free software. Let's head to arduino.cc to get a copy of the latest Arduino IDE. IDE means Integrated Development Environment, and it's where we'll do our coding. You can download this software for free, but there's also an option to make a donation. Arduino, like MeArm, are an open hardware company. This means they give away the software and sell the hardware, but also publish the hardware design so you can build your own or you can copy it to sell if you want. A common phrase is they give away the bits and sell the atoms. Let's get started. So we have the best chance of understanding what we are doing. Let's start by wiring up 1 potentiometer and 1 servo motor to the Arduino. We connect power to the breadboard, red wire to the red line and black wire to the black line. Take a line from that power to the servo motor via the red cable. We take the ground from the breadboard to the servo motor too, using the brown cable. We connect the signal wire from the servo motor to one of the pins on the Arduino board. We can't use any pin though, as it needs to be able to provide what we call pulse width modulation. These pins have a little sideways S on them, called a tilde. Let's pick pin 9 on the board. And finally we need to make sure there is a reference for that servo motor signal wire, so we connect another cable from the ground wire, the black line, to an Arduino GND pin. Next we connect our potentiometer, place it in the breadboard and connect one end of the potentiometer to a GND pin on the Arduino and the other end to the 5 volts on the Arduino. The middle pin on the potentiometer we will connect up to what is called an analog pin. Let's use A0. This is all the wiring you will need for this first part. The Arduino will take power from the USB cable when we plug it in. On your PC or Mac, open the software we downloaded earlier. If you skipped ahead, you can get the software at arduino.cc. We will need to install the servo library. This is simple. Go to Tools, then Library Manager. Or click the icon at the side that looks like a row of books. Now type servo in the search box and click install in the box that says servo by Michael Margolis. Fortunately the code example is written for us. We can head up to File, Examples, scroll down to Servo, then click on the example called Knob. You'll see some text on your screen and this is your Arduino code. The gray text at the top is a comment which will read: controlling a servo position using a potentiometer, variable resistor, which you should realize is exactly what we need right now. Plug in your USB to the Arduino and your computer and it should automatically install any drivers you need. Once it has done this, you will need to go to Tools, Board, Arduino AVR boards, Arduino Uno, then Tools, Port, and select the port that is new for your Arduino Uno. Once we have done this, we can click the arrow key which will upload our code to the Arduino. If everything is okay, then your servo will have probably sprung to life and will have stopped in position. If you turn the potentiometer now, it should move the servo motor in real time. Congratulations, you are 1/4 of the way to having a fully functional robot arm. The rest is easy. We just need to repeat the steps we've done 4 times. Here we start by setting out our breadboard and potentiometers. Connect the 4 potentiometers just like before. Link the 5 volts from the Arduino to the red line on the breadboard. We'll call this our 5 volts power rail. Connect one side of each potentiometer to the 5 volts power rail. Now connect the GND to the black line. This is our ground rail. Connect the ground rail to each of the potentiometers. Then we can connect our wiper pins to the analog pins on the Arduino. We'll use A0 to A3. Let's connect the servo power to the other side of the breadboard to make a 6 volts power rail. Now we connect the signal lines from the servo motors to the Arduino using pins 11, 10, 9, and 6. We'll explain this later. Connect the ground rails together on the breadboard so we have one ground plane. Make sure you don't connect the power rails together as this could damage your Arduino. Now connect all the servos to ground and power. This is the physical setup completed. Now let's look at setting up the code on the Arduino. Looking at the code example on line 12, we have a servo object. We'll need 4 of those, so let's change the name from myServo to myServo0. This is because in coding we number starting at 0. So now let's copy and paste that line 3 times and change the names to myServo1, myServo2, and myServo3. We now have more pot pins too, so again let's change the name to pot pin 0 and copy and paste that line 3 times. Change the names to pot pin 1, pot pin 2, and pot pin 3. We also have to change the references too. So on pot pin 1 change it so it says int pot pin 1 equals A1, so on for pot pins 2 and 3. These should match the wiring you've done for the potentiometers on your breadboard. The next line is int val. Let's make this int val 0 instead. Copy and paste this 3 times and change them to int val 1, int val 2, int val 3. Now we look at the next section, which is under void setup. This is the setup loop. It runs once and sets up all of the things we need in the rest of the code. Let's edit this first line so it says myServo0.attach 11. Now it attaches the myServo0 object to pin 11 rather than 9, which means the potentiometers and the servos will be in the same order left to right as you wired them in. Let's copy and paste again to make myServo1.attach 10, myServo2.attach 9, and myServo3.attach 6. We went all the way from pin 9 there to pin 6 because the pins in between are not PWM pins, so our code would not work on them. Now we have this set up, we can edit the void loop. This is the part that just runs and runs and runs to move the robot arm. First let's edit this to reflect the changes we've already made. So val equals analog read pot pin needs to be changed to val 0 equals analog read pot pin 0, and val equals map val 0, 1023, 0, 180, needs to be changed to val 0 equals val 0, 0, 1023, 0, 180, and finally myServo.write val needs to be changed to myServo0.write val 0. Now let's copy and paste that 3 times and update the vals, the pot pins and the myServos to 1s, 2s and 3s. We keep that last time delay 15 at the end. Now we have to go to File, Save As, and let's call it something simple like knobs, then we can click and upload it. Now if we test out our potentiometers we should find that the MeArm is fully posable and now we can easily pick up and move objects around. There's much more we can do now in terms of making the code more advanced, or making a more advanced controller. One really quick upgrade we can do is change out the twist potentiometers out for nice slide ones. We don't even have to change the code for that. But we'll finish here with this video so we can have some fun with this robot arm. Thanks for watching this video. Please check out our other videos for more great robot projects and don't forget to like this video and subscribe to our channel. If you have any questions or feedback please put them in the comments below.